Hello everyone and welcome to Re-Entry. In this video we'll take a look at how to fly the spacecraft through the Earth atmosphere. In order to fly through the atmosphere we'll need to get onto a trajectory that will actually make us intersect with it. So we're now currently in orbit around Earth, but the orbit is stable, so we are going to need to fire some engines to get us back home. And those engines are located inside of this section here. So we'll need to jettison this rear part, this is the adapter, to expose those engines, fire them at a specific time in order to get back home. Now, once we are done with firing those retrograde engines, we'll remove the retrograde engines to expose our heat shield. The heat shield is located on this spacecraft here and will be facing into the direction of flight. So how do we get back home? So once we're on a trajectory that takes us through the atmosphere, we'll need to carefully maneuver the spacecraft through it in order to not build up too many G's here. And the structural limitation is around 12 G's. So let's open up the mission tools and then data forms and then the blank paper. So let's take a look at how to fly through the atmosphere in Gemini. So if this is Earth and we are flying the spacecraft in this direction, that means that as we are flying through the atmosphere to a splashdown somewhere on Earth, we are going to meet air friction. And this is going to introduce drag. So once we're starting to fly through the atmosphere, we'll get a force that kind of reduces our velocity. So it's like a reverse acceleration, a drag. So how do we maneuver the spacecraft through this atmosphere? The Gemini spacecraft has an offset of its center of gravity. This means that instead of being directly in the centrum of the mass, it has a slight offset. This will make so the spacecraft will have a slight tilt as it flies through the atmosphere. So if this is the air density and we are traveling into this direction, the air will kind of hit the craft and then move around us. The heat shield is in the front here. So the air that travels around us is creating this drag. But since we have an offset of this center of gravity, and let me just redraw this capsule slightly better, give us a little bit more room. Since we have this offset in the center of gravity, this means that we can use roll to tilt the spacecraft. So if the astronauts are sitting inside of the spacecraft and it's steering it, the drag will come in here and it's going to meet the craft. Since we now have a tilt with regards to that center of gravity, it means that more air is going to kind of go one way because there's a tilt to the heat shield. So the heat shield starts to kind of act like a wing. So that means that using roll, we can roll the spacecraft around to decide which direction this wing is pointing. So it's important to always remember that the direction of drag, so let me just draw this up again. The lift direction that this wing is producing is the opposite direction of the head. So if the head is down here and the body and the legs are here, then the lift direction is going to go through the legs of the astronaut. And we can use that to fly through the atmosphere. So we'll take a look at these things pretty soon. But first of all, we'll need to fly through the atmosphere and get onto that trajectory. And in order to get onto that trajectory, as mentioned, we need to fire the retrograde engines. But this should be done at a specific position in order to land in a specific location. And today we are going to take a look at the Retroburn planner to help us plan where to fire those engines. So with the Retroburn planner up, and it's currently set to 1 hour 30 minutes, that means that once the mission timer hits 1 hour and 30 minutes, then the engines will fire, and if that happens, we are going to splash down here. So let us move that a little bit closer to the US. So we can change the minutes to, let's see, 5 minutes difference, 20, that's a bit close. So let's do 23, and this is fine. So at 1 hour and 23 minutes intermission, we are going to fire up those engines. I'm also going to just check if we can do it slightly sooner. So 50, 60, 70, yeah, so this is the best. 1 hour, 23 minutes intermission. So once we're ready and we're happy with a splashdown location, we can update the retrograde timer. So you just hit this button and the retrograde timer will be updated in the computer. Go in here and make sure that it's running. Then we can check if the parameters are correct. So then I'm going to go into the checklists and I'm going to go to the memory core here. And what we're going to try and find is core 19, time to retrograde. So on the computer, let's hit clear, type 19 and read out. And it says that the retrograde burn will happen in 59 minutes and 31 seconds. And that seems quite right. So now I can close the Retroburn planner, and we have verified that the parameter is set correctly. And now we can start with the entry and deorbit procedures. So again, let's go into the checklists, and we're going to use some time scaling to get close to that pretty soon. But before we do that, let's open up the mission pad checklists and take a look at the entry section here. So we have pre-retro, 256 seconds to retrograde, which is 4 minutes and 16 seconds before. 1 minute to retro, post-retro jettison, entry, and then we have landing and post-landing. So these checklists will basically be run in sequence. So let's queue up the pre-retro checklists first. Now, also, we can timescale, let's say, let's timescale to about 50 minutes. Just so we have enough time to get through everything. And then verify, we can hit readout again to update the time. So in 32 minutes and 39 seconds, we are going to fire up those engines. So first is the sequencer light test. It's a very simple test that you can do if you want. We can switch it to amber, see that things are working, switch it to red, and we can see the lights are all illuminated, which means that all our light bulbs are working. Then we need to configure a couple of systems. So let's go into platform, blunt end forward, since we are going into a retrograde burn. That means that we'll need to fly in the direction where the engines are pointing into the direction of flight, which means that we are then going to slow down. Now we are going to set the event timer to 20. So first of all, we'll need to make sure the event timer is stopped, and we can set it to countdown. And then we can use a mission tool here and cockpit functions, and we can say reset event timer. You can also do it manually using this selector here. And it wants us to set this to 20 minutes. So we'll just set it to the maximum speed in counting up. There we have 20 minutes. It's now set to countdown, and it's currently stopped. Okay. Let's continue with the retro checks. Battery test, and we can check if all of the batteries are working. Battery 1 is working, battery 2 is working, battery 3 is working, battery 4 is working, which means that we are good to go. Okay, now we need to wait until we're 20 minutes before the burn, and you can do that by just spamming readout here, or you can do some math. We are now 30, so once we're at 103 means that we are going to start the timer. So let's time scale. So in 30 seconds. Five, 4. So I'm just using this second-hand visor. Once we're at up here, we should be good. 6, 5. Okay, then we'll just start it, and it doesn't need to be precise if you don't really want to, but try to get it within a second or two. All right, so then we can set the computer to re-entry. This will now start to load the re-entry programs or software from a tape into the computer memory. So you can see that the tape light is illuminated, which means that the tape is running, and that means that the computer is loading its software. And this typically takes 10 minutes. And this is also one of the reasons why we need the event timer to help us counting down, because this one is not working correctly when the tape is loading. It's not refreshing, so the computer isn't running the software. So now we can use the time scaling again, and we'll wait until the light is off. There we go. And then we can start the computer. Now we should be able to refresh the time. So we have 11 minutes and 50 seconds left, which is somewhere close to this event timer here. Okay, the next thing that I want to quickly do is to correct my attitude slightly. And I can go into direct, and I'll correct my roll. I'll go rate command to stop the rates. Also check our fuel levels. We are good on fuel. You can see the fuel quantity here, if this is set to ohms. Okay, and then we can return back to platform control. Now the autopilot will basically try and hold us somewhere close to this attitude here, and this is now in the retrograde direction since this is set to blunt and forward, BEF. Alright, next let's proceed with the checklist. So this is 256. We can just start to run it now, because one of the first instructions here is to wait until the event timer is 4:16. So let's go ahead and do that. Minute. Go. Now we are going to connect the main batteries, enable RCS, check the fuel levels of our RCS system. Those are basically the jets that are going to be used to steer the capsule once we jettison the adapter section. Then we'll switch the control mode to rate command re-entry, and then we can turn off the ohms. The ohms is basically the system that is in control of attitude and translation right now, but we're going to jettison the adapter, which also takes away the ohms. So now we need to connect the RCS and power it. Next, we are going to go through the sequencer here. So first you want me to press this button. It will offset the attitude slightly for entry. And then we are going to enable RCS. And let's check our attitude. It seems to be good. About go. So 20-degree pitch down. Configure the pilot side as well. The next thing to do is to start the 1 minute to retro checklist. 1 minute to retro. Now we need to wait for that cue. So we're about 2 minutes away, and let's verify this one. Good. Timescale. Okay. 1 minute. Okay, we are still in attitude. It's always important to check the attitude. Now we don't have a lot of time to fix it at this stage. But luckily we did it at the 4 minute mark as well. Now we are going to separate the ohms lines, separate the electrical lines, and then separate the adapter. Okay, the adapter has been separated. Now we're waiting for 30 seconds, which is now. Let's arm the 4 retrograde rockets. 5 seconds before. Always use this block here as well. There's one on both sides. Arm. Wait. There we go. Manual fire. did that. So now we're waiting for the time to retro plus 30 seconds. The current software, the re-end software, it has now tracked our delta V during the burn. So it started at 0, and once the rockets ignited, it counted that we traveled, made a change of this amount in the forward aft direction and this amount in the up down direction. 30 seconds plus, we are good. Now we are waiting for the 45-second mark to arm the retro engine jettison. So there we go. We can jettison it. Okay, we're now done with the sequencer, and if we now open the map view, you can see that we are on an orbit which has perigee 58 nautical miles of altitude below the horizon. So we are now going to fly through the atmosphere. So let us bring up the next checklist. That's the post retro jettison. It's going to basically just depower things and prepare us for atmospheric flight. And arm the landing squibs. These are basically responsible for some of the pyros. Take note of the delta V vector, that's done, and then start the entry checklist. Entry. And this doesn't have a run feature, but this is basically about just flying through the atmosphere. So 0 degree in yaw, and we're going to have a roll initially at 170 degrees. So the horizon should be at the top of the window. And then we are going to roll the spacecraft to ensure that we stay below that 12G limit. Obviously, our target is to be between 3, 6, and so on. So let's turn. The checklist wanted us to have the horizon at the top of the window. And if we now recall from our initial 10 degree roll, so 170, recall from the initial drawing that I made, now I'm upside down, which means that my head is pointing down towards Earth. This means that our wing, or the heat shield, is slightly tilted to make us climb in a way. So once we're going hitting the atmosphere, it's going to build up that lift vector upwards. And if I would turn the spacecraft around like this, the lift vector is now pointing down, which means that in this attitude we'll be pointing directly the lift vector directly down, which means that we are going to dive straight down into the atmosphere. But initially we want that lift vector to be pointing upwards. In the Gemini craft, we don't travel fast enough to properly be able to skip out of the atmosphere. But what will happen is that if you fly in this attitude all the way through the atmosphere, which means that the lift vector is pointing up, means that we are going to stay longer in the atmosphere and we're going to cover more distance on Earth. So this means that if we constantly try to fly upwards, we might splash down over here. And if we would dive down and stayed with the lift vector pointing down, we could land way earlier. But obviously we would also most likely hit that and exceed that 12 G limit. So heads down, lift vector up. Now we can use timescale until we hit that entry interface, and there's going to be a message once that happens. There we go. You have crossed the entry interface at 400,000 feet altitude. Prepare for entry and atmospheric drag. So now we are going to make sure that we have Earth at the top part of the window. And once we see this thing here is starting to count down, we can then roll the spacecraft to direct that lift vector downwards, which means that we are then going to descend deeper into the atmosphere much faster. And I'm saying this again and again just to make sure that you kind of learn how this craft operates in the atmosphere, and you'll of course see this in action pretty soon. So I can use timescale a little bit more until it automatically stops. There we go. Now we have met some of that atmosphere. This is still in the upper part of the atmosphere, so we don't have a lot of G's left yet, but we can monitor this and see that it's going to be starting to build up soon. And we also have our lift vector now pointing upwards, which means that you won't be able to exceed those G limits at the current trajectory that we're on. So if you want, you can just fly like this all the way through the atmosphere and you would land, you would exceed the landing zone by a lot, but that's fine. What this will do now is that it's going to count down towards the landing zone. So if you want to try and land exactly where it's estimated that we will land, then once those chutes are released, this should be 0. But most likely we are going to go through a little bit faster today, or if we would stay like this, we would overshoot and go way beyond the landing point. So that's kind of how this works. It's always good to prepare the landing checklist as well. So I'm just going to get up here, just so I'm ready to start releasing the high altitude drogue. Okay, we have now seen that we are counting down. So let's roll the craft, and I'm in re-enter rate command. Select that heat shield, so we can start diving down. We're still in the upper parts of the atmosphere. We don't have a lot of G. It's a fraction, so we'll just continue to fly like that. And now you can see that this is what I mean. So the air is coming in here and it's hitting this wing, which then creates a lift, which points down because the wind comes here, or the air density, which pushes us downwards. The wing is kind of tilted, the angle of attack basically, which will push us down into the atmosphere. Now we're waiting for that G to start building up. And in this case, just to kind of be safe compared to just trying to hit 0 here, is that I'm going to roll back to lift vector up, which means heads down. So now we're heads up with lift vector down. And at 3G, I'm going to roll, so my head is pointing down and the lift vector is up. That will reduce our vertical speed and our descent rate. At 1G. Typically when I'm flying through here, I'm making sure that I can see the window, so I can see if Earth is below me or above me. It's always good to have a visual, but I can always see that on the attitude indicator here. And then we have the G, so now I'm going to roll. Now you will see that once the lift vector points upwards, so now we have heads down, lift up, you will see that this G is now going to stop, and then it's going to slowly go backwards towards 3 and so on. If I would have stayed in the other attitude, which means lift vector down towards Earth, I would have exploded by now. I was a little bit late on my roll, so I started the roll at 4.5 Gs, and you should start it at 3. And if you don't, you see that I was cutting it quite close to 12 Gs for now in my attempt here. So now we can roll back. And at this point, if you want, you can go ahead and do what we've done in Gemini, and that is to build up a steady roll. So I can switch the entry mode to re-ent, which is direct, and then just have a steady 10 degree per second roll. 10 degrees per second is here. Now it's going to start to continue to build up, but it won't exceed the 12G limit, because I'm now having a constant roll. And if I would like to be longer in the air, that's traveling longer on Earth, to reach that, I should have now pointed my lift vector upwards to kind of extend the length that I'm going to be flying through the atmosphere. But that's fine for now. You can see the altitude is now below 100k, which means that we are soon through the atmosphere. These are reducing, and now we're waiting for that 40k light. Stop my rates. Back to command. Right. I out broke. It's out. See it there. And we have the D ring, which is already on in my case, but you can toggle that using the toggle D ring. Let's continue with the landing checklist. Now we're waiting for the 10.6k altitude sensor to kick in, which is the point where we're going to be releasing the parachute. You can see your altitude here. 20,000 feet of altitude. Feet. So that's basically how you fly through the atmosphere. Always be aware of the direction towards Earth. So where is the lift vector currently pointing? And is always pointing from your head through your toes. So from your head through your toes. So if you're upside down, the lift vector is up, and if you're you're normal, you have Earth in the low part of the window, the lift vector is down through the atmosphere. So now we are getting closer to the main chute. Right, so that's 10.6. There we go. We have chutes, and then we can switch into the landing attitude, which basically cuts a rope in the chute, but just one, that will make us kind of tilt downwards like this. So it's now kind of floating down like a boat, and we're going to be landing in the ocean in this direction here. That's the landing attitude of the Gemini craft. See, after main deploy, then we have a couple of systems to continue hovering down. Panel, right hand panel. Oh yeah, and this is where you toggle it. So basically at 2K altitude. And now all there is left to do is to wait for the craft to splash down in the ocean. So flying through the atmosphere is very much an instrumental thing. You'll need to constantly monitor your G loads, and it's always going to be quite reactive. So make sure that you don't exceed that 3-4 Gs before you do the roll maneuver, or roll reversal is what they typically call it, to direct that lift vector upwards again. And then after that, you can fly however you like in terms of how you want to reduce this distance left to the estimated or predicted landing location. (350 feet). 100 feet. And prepare for splashdown. Right, and splash. The next checklist to run through is the post-landing checklist. I'm not going to go through all of this now in this video, but basically it's just depowering everything and extending the HF antenna control and so on. So with that, I hope that this will help you understand how to fly through the atmosphere and prepare you for entry in the various Gemini missions. So good luck and thank you for watching.